Our topic is about factoring trinomials. Now we have here four examples of monic quadratic trinomials. Now it is in the form x squared plus bx plus c. Now it's called monic because the leading coefficient is 1. That means the coefficient of the quadratic term is 1. Now let's factor this. X squared plus 13x plus 42. Now factoring a quadratic trinomial would result in the product of two binomial factors. So I'll write here the two parentheses. Now this will house the two binomial factors. Since that is x squared, I write here x and an x. So x times x is x squared. How about the signs of the terms here? Since this is positive, the signs of the two terms must either be both positive or both negative. But since the sign of the middle term is positive, therefore both are positive. So I'll write here plus and a plus here. So how about the numbers? We need to get the right factors of the constant term 42 such that their sum must be equal to the coefficient of the middle term. Now let's get the factors of 42. Now let's try 2 times 21. So 2 times 21 is 42. If I place 2 here and 21 there, that would be 2 plus 21. So that's equal to 23, but we're looking for 13. So this is not the right pair. So let's try another one. How about 6 times 7? So 6 times 7 is 42. If I place here 6 and the 7 here, that would be 6 plus 7, and that's equal to 13. Exactly that number. Therefore, this is the right pair of factors. So I'll write here 6 and 7 here. So 6 plus 7 is 13. Now let's check if this factoring is correct. Now using the FOIL method, we're going to expand the product of these two binomial factors. F for the first terms, that's x times x is x squared, right there. O for the outer terms, so x times 7 is 7x. I for the inner terms, 6 times x is 6x. So 6x plus 7x is 13x. So that satisfies the middle term. L for the last terms, 6 times 7 is 42. Right there. Therefore, this factoring is correct. How about the next one? That's x squared then, so we could write here x and an x. How about the signs of the terms? Since this is negative, the sign of the constant term, the signs of the terms here must have one negative and the other positive. Since the sign of the middle term is negative, I write here negative and the other positive. Although they are interchangeable, I purposely wrote the negative sign here because I want to place the larger factor here and the smaller factor there. So let's get the factors of 45. Let's try 15 times 3. So 15 times 3 is 45. If I place 15 here and the 3 there, that would be minus 15 plus 3 is minus 12. But we're looking for minus 4. So therefore this is not the right pair. So let's try another one. Let's try 9 times 5. So 9 times 5 is 45. If I place 9 there and the 5 there, so that would be minus 9 plus 5 is minus 4. So therefore, this is the right pair of factors. So I write here 9 and the 5 there. So minus 9 plus 5 is minus 4. So we're good with that. So let's check if this factoring is correct. X times x is x squared. X times 5 is 5x. Minus 9 times x is minus 9x. Minus 9x plus 5x is minus 4x. So it satisfies the middle term. Negative 9 times 5 is negative 45. And therefore, this factoring is correct. So let's try this. So I write x and an x here. The sign of the constant term is negative. Therefore, the signs of the terms here must have one negative and the other positive. Now, since the sign of the middle term is positive, I write here positive and the other negative. So positive times negative is negative. Now, the reason why I place the positive here is because I want to place the larger factor here and the smaller factor there. So let's get the factors of 30. Now let's try 15 times 2. If I place 15 here and the 2 there, that would be 15 minus 2. That's equal to 13. But we're looking for positive 7. So this is not the right pair. How about 10 times 3? So 10 times 3 is equal to 30. If I place 10 there and the 3 there, that would be 10 minus 3 is 7. Exactly that number. So therefore, this pair is correct. So I write here 10 and the 3 there. So 10 minus 3 is positive 7. So we're good with that. So let's check if this factoring is correct. So that's x times x is x squared. X times negative 3, minus 3 is minus 3x. 10 times x is 10x. So 10x minus 3x is 7x. So it satisfies the middle term. 10 times negative 3 is negative 30. So therefore, this factoring is correct. How about the last one? So that's x squared. I write here x and x. The sign of the constant term is positive. Therefore, the signs of the terms here must either be both positive or both negative. But since the sign of the middle term is negative, so both must be negative. Now, let's get the factors of 32. So let's try 2 times 16. So 2 times 16 is 32. If I place here the 2 and the 16 there, that would be minus 2 minus 16 is minus 18. But we're looking for minus 12. So this is not a pair. So let's try another one. How about 4 times 8? So 4 times 8 is 32. If I place 4 here and the 8 there, that would be minus 4 minus 8 is minus 12. Exactly that number. So therefore, this pair of factors is correct. So I write here 4 and the 8 here. So minus 4 minus 8 is minus 12. So we're good with that. So let's check if this factoring is correct. X times x is x squared. X times minus 8 is minus 8x. Minus 4 times x is minus 4x. So minus 4x minus 8x is minus 12x. So it satisfies the middle term. Negative 4 times negative 8 is positive 32. Therefore, this factoring is correct. Now, if you find this video useful, please hit the like and subscribe to my channel. It means a lot to me. Thank you.